Hello students, in this video we are going to do a numerical based on lenses like previous video. But in this video I am going to teach you the art of drawing ray diagrams. You may think, is it a very big thing? You need a compass, you need all that stuff? No. I will tell you a simple way of drawing. What you just need is a 30 centimeter scale and a pencil, and you need a eraser. These are the basic necessities to draw a neat diagram. This is the art of drawing ray diagrams. Here I am going to draw a concave lens. You see what I am doing? I am taking my half meter scale and I am going to first draw dotted line. And this dotted line stands for the optical axis. The lens is thin, so I don't worry. Now what I do, I keep it like this, draw like this. Okay, I am not doing anything here. I just take freehand curve and I draw like this. And the other part of it, I take it and I draw a freehand curve like this and I close it. Don't think it is difficult, right? You don't need a compass or you don't need anything else so difficult to do it. You just need a little bit of freehand drawing the curve. Yes? Now, you know, let us fix the optical center. Now, what I am going to do, your answer sheet or your notebook is small, but my green board is too big. So naturally I need a bigger scale, but I am not using it. Now, you have the scale. So optical center is marked. Okay. First let us fix the focus. Concave, it is going to be the focal length or focus. Okay, forget about even that first now. Let me take here around 60, this is 80, and again 60, and this is 80. Little patience you need. This is F and this is 2 times F. Here we don't use center of curvature. This will not work here. 2F is equal to R will not work in the case of a lens, because its radius of curvature is different. Now I have taken here, so same value I need to take it here. This is 20 and from 80 another 60, this is 20, right? And this is F and this is 2F. Now in the concave lens we should know which is the focus, right? Now for me, I am taking the light from left hand side and it is passing through the lens and it is going to come here. But we know that the ray coming parallel to the principal axis will diverge. When it diverges, there is no focus at this point. It cannot meet there. So we extend it backward. So this is going to be our focus. This is going to be the focus for us. So our focal length is in the left hand side. So this is the focal length. Let us say I keep the object somewhere in this point. I keep the object here in this point, and this is the object distance RU. Now we don't know where the image will form, but theoretically we know where the image is formed. Let us not worry about it. Let us find out mathematically where it will come. Okay, let me take a problem now. Let us say whether I have this problem. Let me check it now. Yes, the focal length, we will take it as 10 centimeter. And we will take the object to be lying at 15 centimeter. We need to know where is going to be V. We have the formula 1 upon F is equal to 1 upon V minus 1 upon U. So let me take the data first. What is the data? Focal length. Focal length is 10 centimeter. According to Cartesian coordinate system, keeping the optical center as the reference, it is in the left hand side. So just to put a negative sign. Next object distance u is equal to 15 centimeter. Again, it is also lying in the left hand side. So blindly put a negative sign. And we need to calculate v is equal to how much. So 1 upon f is equal to 1 upon v minus 1 upon u. That is 1 upon minus 10 is equal to 1 upon v, which we don't know, upon 1 upon minus 15. That is 1 upon minus 10 is equal to 1 upon v, minus of minus is plus 1 upon 15. Bring this 1 upon 15 this side, right? So 1 upon v is equal to, I am retaining it this side only, okay? I am shifting this side. 1 upon minus 10 minus, here it is plus, it comes this side, minus 1 upon 15, right? As usual, we know the common denominator is 30. And this will go 3 times, so minus 3 minus, this will go 2 times, that is 1 upon v. That is going to be minus 5 upon 30, which is equal to 1 upon v. Fine, there is a negative sign here, this and this will go 6 times, okay? So v is equal to minus 6 centimeter. I hope you understand. It's not very difficult. Once you know the Cartesian coordinate system or sign convention, it should be very easy. Let me cross check it slightly, right? Focal length, this is come 1 upon v, yes, I substituted it correctly and I took it over to the left hand side, that's correct. LCM is correct and I calculated 3 times and I calculated it 2 times, yes, it's correct. So once I know that 6 centimeter, where is 6 centimeter? Minus 6 centimeter, left hand side, it is going to come somewhere. This is 5 if you take, the v is going to lie in this side here, and this is the, theoretically also we have done it, and this is the image. That is where the image distance we have got it, and this is the object we got it. So be clear about this. Now again you can do the same formula with magnification, which is equal to v upon u. Magnified or diminished has become bigger or become smaller. It's a very simple term there. So we have the values. Let me erase this whole thing here. M is equal to v upon u, which is equal to v is minus 6 upon u is minus 15. So minus and minus goes plus. 6, 3 we can try, 2 times, 5 times, that is 2 divided by 5, that is 20 upon 5, 0.4. So magnification does not have unit, is 0.4, that means it is less than 1. When it is less than 1, naturally the image is diminished image. The image is diminished image, and it is erect image. Why is it erect? Because this turns to be a positive value. Fine. And otherwise we know that it is a virtual image because it is forming at in the same side as the object. So naturally these are the conclusion we derive at this formula. So you learnt about this. Now I want to do another type of problem which will make you different types of problems can be done. The physics is all about concepts and also about numericals. The concepts will make you strong fundamentally, theoretically, and the numericals will strengthen your concepts. So doing numericals, though may look difficult by practice, right? You do minimum number of problems. You need not do 100 problems because you don't worry first about cracking IIT or cracking NEET examination. First you need to crack the board examination. Once you clear the board examination, then when you prepare for that, you become confident. When you parallelly prepare for either IIT main or NEET, without the foundation, you cannot construct the building. And the same way, learn the concepts, do the numericals, and check the previous year question papers, and that will complete the cycle for you. Right. Now, I am going to take a problem from your NCERT textbook of 10th standard. As I said to you, derivation is there only in 12th standard. Again, art of drawing the lens, center point, optical axis, one freehand curve, another freehand curve, join the upper and lower part, lens is ready. Now, join with the optical center. For rough diagram, is this much also is enough. Now, the problem is given. Say simply you mark here F, mark here 2F, mark here F, mark here 2F, approximately. You see, you can keep your hands like this, fingers like this, gun from here, here. That's all. Very simple. You don't require even a scale now. You know the art of drawing ray diagrams. Okay. In this problem, focal length is given. F is equal to, what is the data given? Focal length. Focal length is 15 centimeter. You know F is this side, so it is negative. Next, where should an object be placed? Where should an object be placed? So U is equal to how much now? Every time we are doing with V. Now here U you have to calculate. If the image is formed at a distance of 10 centimeter, you already know that in the case of a concave lens, it will be virtual and it will fall in the left hand side. So no one need to say anything to you, put a negative sign. It cannot form anywhere else. It has to form in the left hand side for a concave lens. Now, he says that calculate the U, and also if possible we can calculate the magnification. Yeah, let me just do this numerical. Yeah, formula 1 upon F is equal to 1 upon V minus 1 upon U. Yes, 1 upon F minus 15 is equal to 1 upon minus 10 minus 1 upon U. Here we can work out, okay, let us go slow on that. Keep it as it is here. Or I will suggest one thing, shift this whole thing to this side. Okay, minus 1 upon U will become plus 1 upon U, which is equal to, keep this down, minus 10. Minus comes this side, it will become plus 1 upon 15. Our job is done. This has been shifted here, and the other one has been shifted to this side. Yeah, that is equal to, as usual, 30 is going to be the LCM, and 3 times it will go, but there is a negative sign, plus 2 times it is going to go. That is what? 1 upon U. Always in the left hand side, 1 upon U, 1 upon V, 1 upon F, 1 upon R, 1 upon C. Go on. Don't leave the left hand side. If not, you will get confused. Okay, so that is equal to minus 1 upon 30. Fine. So minus 1 upon 30, which implies that U is equal to minus 30 centimeter. Yeah, look at it here. Image is formed, focal length is 15, object is at 30. Okay, this is 2 times 30. Object is placed here at this point. And the image, where was the image? It was formed here. So all of them will hold good, because numerically the formula, if you apply correctly, the answer will come and fit just like a jigsaw puzzle. Right? Now I need to calculate magnification, which is V upon U. What is V? V is minus 10. Minus 10. Don't leave the sign. U is minus 30. cancel these two, that is equal 0, 0 goes 1 upon 3. 1 upon 3 is nothing but 0.33. This is the magnification. Now you see the magnification less than 1. So that means it is diminished. Image is diminished, positive, erect image, and it is falling in the left hand side. So it is virtual. So with this you have covered all the points on it, and you remember this, and you can be able to do any problem. I want to say a small point here. Power of a lens you will come across, that is 1 upon focal length. Power of a lens is 1 upon focal length, and focal length is measured in meter because it is SI unit, and this is measured in diopter, right, diopter, okay, capital D, okay, plus, minus and all you can use, but this should be in meter. If it is in centimeter, then you have to be careful. You put 100 upon F if it is going to be in centimeter. This is useful to do numerical. I'll tell you a simple example. When you go to have a problem, eye problem, and then you get a lens being made, the power of the lens he will measure in diopter. He knows what should be the thickness of the lens and all this stuff. So this is if you see my specs, it has broken up last a week back. So I changed the this frame, but the frame and the lens are not matching. So I have difficulty in getting a clear object vision. So I have made I have given for a new lens, new specs, because everything to the point, the clarity, the image cannot be fuzzy. So a clear image, if you don't get a clear image, you will get a headache, because eye is connected to the brain, and even if you strain too much and study, either using a mobile or using a computer or even a textbook, the stress will cause you. That's why some of you will be wearing, doctors will advise you to wear a specs of 0.25 diopter. 0.25, a simple number, right, that can be removed later at some point of time, because that is due to stress. With this, I complete this video, and thank you. We will see in the next video.